Hi, I thought I would do a third demo of this app. It's been a week since the last one, a little more over a week. So a whole week new data and a whole week of new releases and changes. Um, I don't really know why I'm doing this. It's a little crazy, but I can't seem to stop. So thank you for watching. If you're using the app, by all means, email me and ask for things. There's about 1,000 installations according to Splunk-based analytics, but that doesn't really mean anything. And it's not a particularly big number in Splunk-based terms anyway. So I'm just kind of doing this partly for me and partly to inspire other Splunkers, and mostly really, I don't know why. Mostly, I don't know why. Pandemic curves. You can search for these. A lot of them, for some reason, show the tail half being symmetrical with the front half, which is false. That's not what they look like at all. This was a little better. You see it's a little fatter on this side. So this is a strange thing that's been kind of irritating. Here's one. Big surge, exponential phase, a hump, and then slowly decaying away. So you can see that a little bit here. I've pulled up China versus Italy. The x-axis is time. The y-axis is linear, not logarithmic. And this is showing the actual patients who are still sick or testing positive and they haven't recovered, but they also haven't died. So they're patients in the system. There's a hump. There's a number of charts that each have hump. Well, there's a number of things that have the worst part. So the worst part isn't one single part. It's lots of different things. Let me show you. Deaths per day. So I see the hump of this one was around day 27 for China, and the hump of Italy, we're not there yet. It'll be over here. So day 27. Let's look at deaths per day. That's certainly one that goes up in the middle and then comes back down. And you can see China was long ago surpassed by the scale of the pandemic in Italy. I should add on New York here, but the app allows you to compare states versus cities. You can fold that back up and treat US as a country again, but I haven't been doing that. It doesn't make a great deal of sense. It's so local. You can actually go to counties using this tab here and analyze county by county in your state. I'm not really going to do that on this demo because there's just which county would I use, but you can. So there's a deaths per day over time. This is so 760 people died, 800 the day before, 799 the day before, so on and so forth. This one has a hump and will come back down. You can see both New York and Italy long ago dwarfed the scale of the disaster in China. China Hubei is the province in which almost all of COVID-19 cases were in China. So skipping ahead, how do we, the first question back here in the super terrifying days was, what are the doubling times? Are the doubling times different for each state, different for each country? To what degree do they cluster together? That was the first impetus for me to create the app. And then quickly it became, let me switch to a logarithmic axis here. So initially, let's just use New York. New York is the blue line here. Well, let's change this to 100th. If you normalize to a different statistic than you're charting, then funny things happen on the chart. So here, when these were straight lines, we were clearly in an exponential phase. So there was a doubling time, and you can see it was really super short. It was literally 2 days. This was like hair on fire, terrifying, because that number quickly got up into, millions of dead up here. You can't see really where my mouse is going, but no good. Actually, I guess millions would be here. This would be millions of dead where my mouse is. So that started to flatten out, and we had much longer doubling times. This was now like a while ago, and then it was clear like a week ago that New York was coming out of the exponential phase, and just from monkeying around with the data, I was able to see this myself, even as an amateur non-epidemiologist Splunk user. And what I did is I put together this. This is a funny statistic that is really just created on the fly. And it is essentially, of the people who were admitted to, say pick a hospital, of the people admitted to that hospital on that day, the new cases that come into the system with, that are diagnosed or testing positive, you can estimate a proportion of them that will become fatal cases, and you can compare that number with the number of cases that did actually die today. And the ratio of those will tell you something about whether the deaths is going to go up in the future or not. So this is that delta charted out every day. And if I skip ahead, actually, if I reset this to all US states, and then maybe let's add Italy back in let's add Italy and Spain. They just, unfortunately, make good reference lines. And I really wish that they didn't, but they have so far. And then we come back to this tab. You can see the point happened a while ago where this metric flipped over for Italy. Sorry, the time values are in epoch time. It's kind of annoying. But what this means is that the number of deaths was still really high. And so this looks small, only 100, but this is the delta between the expected deaths, extrapolating the case fatality rate against current cases, delta of that versus the actual deaths. So there might be 900 forecasted fatalities and only 800 actual fatalities that day. And so there's a green line here. So this doesn't tell you much about the magnitude. It tells you a little about the magnitude, but it does mark the point where so skipping ahead, you can see what they saw. I'm sure, I hope, God help us all, if public health experts have something better than this, that they saw the same thing. And they're like, well, at least that's happening. At least the load on the healthcare system is going to go down in the future. Not quite yet, but we can see that fewer people are going to die soon. But this doesn't help the actual deaths over day, the deaths by day. So I said this actually a week ago. Once we come out of the exponential phase, unfortunately, there's still a long and extremely painful linear phase remaining. Let's actually take away. I need to have a little save thing so I don't have to keep reconstructing my lists here. It's very tedious. I apologize if any of you have been using this and finding the same thing. Again, we're comparing deaths and cases. So this is logarithmic axis, which is weird because, well, clearly these aren't straight lines, so we're not supposed to be using a logarithmic axis, so let's switch to a normal. So this was back here was the exponential phase, and we left that. Now we're in this linear phase where 800 people are dying every day, about 700, 900. And we're going to chart out the same shape that Italy and Spain are charting out. Whether New York's will be bigger or smaller is a good question. The next questions really are, well, when is it going to start falling out of this linear track? That's actually fairly simple math to chart out. And of course, is this going to happen to all the other states, to all the other countries that are not where New York and New Jersey are in the math? And one thing, this chart is showing remaining patients sick. My x-axis is showing days since each state had its 100th confirmed case. You can see the longest lines are the lines that are higher up. By definition, that means the lines that are higher up had at some point a really short doubling time. They had one of these 2-day doubling times back at the beginning. And 2-day doubling times are really terrible, as any New Yorker can tell you right now. But the states that only had their 100th case recently are enjoying much, much flatter growth curves, much flatter, because they're not having big parties and staying out late at a bar. They're not doing any of these things that we were actually all doing 33 days ago. So what may become a question is monitoring all of this really accurately, attentively, to see whether any of these lines are ticking back upward, and see whether any metrics like this metric are ticking back into the red. So thank you for watching this. I didn't really have a plan on what I was going to say here, unfortunately. If you're using the app, please let me know. If you are interested in anything about the app, you think it should have something, let me know that too. There is actually a to-do list hidden in here, as well as notes about this and that, and release notes. You can see there's been a crazy number of releases for something that is free, and I don't even know why I'm doing it. If you want to use it and you don't have the ability to install Splunk anywhere, let me know. I don't know. I can fire it up on Zoom and we can talk about it. That's a thing. Anyway, if you can't find my email address on the internet, you're probably not looking very hard. And but it is nick@sideviewapps.com. And that's it. I'll try and shoot another one of these. There's a build of this app every day. In the next day or 2 or 3, I would expect that I will finally finish the work to make this app go back to pulling down data dynamically. So you won't have to update it every day to get the new day's data. Stay tuned for that. If you go to Splunkbase, I'm not going to go there right now, but if you go to Splunkbase, you will find on the COVID-19 apps page, you'll see a little subscribe button. I think it's called subscribe. If you click that, it will email you every time that there is a new release, which of course will be every day, and you can then update your Splunk instance. Okay, thank you.